Let's jump right in. What we're looking at today isn't some standard travel guide. No, it's something way more ambitious. We are digging into a master production blueprint for a cutting-edge 3D animated documentary. We're going to deconstruct the exact specs needed to digitally build an entire country from the ground up, literally pixel by pixel, rendering by rendering. It's an absolutely fascinating look at the heavy lifting required for modern digital world building.
Take a look at this directive, straight from the source material. It demands ultra-realistic 3D animation, physically accurate lighting. Honestly, that pretty much tells you everything you need to know about the highly technical, incredibly cinematic medium we're exploring today. We're definitely not talking about stylized cartoons or those basic architectural fly-throughs. The mandate here is absolute digital photorealism. The ultimate goal? To totally trick the human eye using advanced 3D animation techniques, creating a living, breathing virtual replica of a nation.
So, the core mandate here is incredibly specific. It calls for a highly detailed, 5-minute, 4K high-definition cultural odyssey of Germany, all rendered entirely in 3D. And it comes with a super strict creative constraint. The content must be historically and culturally accurate. Every single pixel, every texture, every camera movement, they all have to work together to create an immersive atmosphere that feels undeniably authentic. It's essentially compressing a massive geographical and cultural landscape into a concise, punchy, 5-minute digital showcase.
Okay, let's dive right into our roadmap for this explainer. First, we'll look at rendering the technical foundation. Then, building lifelike 3D environments. After that, we'll tackle animating crowds and culture, before finalizing the render output. Let's get started.
Section 1. Rendering the technical foundation. Focusing on mastering light and atmosphere.
Establishing these technical rules is always the first major hurdle of any 3D animation project. You have to lock this down before a single environment is even built. And this source material, it lays out some incredibly demanding constraints. It specifically requires ray tracing, which, if you don't know, realistically simulates exactly how light bounces and interacts with objects. It also demands 4K HDR quality, volumetric fog for that thick atmospheric density, realistic depth of field, and completely physically accurate lighting. Plus, all of this has to be framed using professional documentary cinematography. We're talking epic drone shots and ultra-smooth camera movements. Achieving this level of true cinematic realism means pushing modern 3D rendering engines to their absolute limit. It's the kind of project that requires a render farm that probably sounds like a jet engine taking off.
All right, moving on to Section 2. Building lifelike 3D environments from forests to factories.
Now, what's really fascinating here is how that incredibly heavy technical foundation we just talked about actually has to be flexible enough to support wildly diverse geographical and architectural locations. It perfectly illustrates this massive dual artistic challenge for the 3D environmental artists. Think about it. On one hand, they have to master organic landscapes. They need to render the chaotic, natural textures of dense forests, the flowing water of the Rhine River, complete with cruise ships and vineyards, by the way, and the colorful, flower-filled balconies of traditional Bavarian villages. But then, they have to seamlessly pivot to hard surface modeling for industrial scenes. We're talking mathematically precise representations of the Autobahn with luxury cars and advanced auto factories featuring intricate robotic assembly lines. The 3D engine basically has to handle the total chaos of nature and the strict precision of engineering with the exact same level of photorealism.
And here's the kicker. It's not just about what is being rendered, it's about when. Across the 10 required scenes, the lighting engine has to dynamically handle a full chronological progression. The blueprint actually dictates a cinematic aerial sunrise over modern cities and mountains to open the piece. Then, you need these bright daytime setups for exploring sites like Neuschwanstein Castle. And finally, the lighting has to flawlessly transition into a nighttime setup for the big finale, the Berlin skyline, complete with glowing city lights, fireworks, and a waving German flag. Actually, lighting a sunrise requires a completely different technical setup than lighting glowing cityscapes and pyrotechnics at night. It's a massive undertaking.
Which brings us to Section 3, Animating Crowds and Culture, the Character Challenge.
We are now moving into what is universally considered the absolute most complex, time-consuming part of any 3D animation pipeline, and that is populating these beautiful digital environments with highly realistic human models. The source document outlines a super strict definition for lifelike environments. It explicitly requires showing 15 to 25 realistic 3D human characters naturally interacting in every single scene. Just think about that from an animation perspective for a second. animating up to 25 distinct human beings with realistic facial expressions and natural movement in every shot. That is an immense technical feat. They aren't just dropping in static background figures. The prompt demands natural interaction and totally lifelike behavior.
Let's look at a few of the specific character briefs to really understand the scope. At the Brandenburg Gate, animators have to create tourists, local families, cyclists, and street performers. Down in the Bavarian village, they need locals in authentic, location-appropriate clothing. For the Oktoberfest scene, the requirement scales way up to realistic crowds enjoying food, music, and complex cultural celebrations like folk dancing. Then, over in the universities and tech centers, they have to animate students, scientists, and engineers actually working collaboratively. Every single character mesh, every piece of clothing, and every animation cycle absolutely must maintain historical and cultural accuracy. No pressure, right?
Finally, we reach Section 4, finalizing the render output, bringing it all together.
So after the lighting is completely dialed in, the diverse environments are built, and those complex character meshes are fully animated, the final output parameters have to be locked in to bring this entire digital world together. The crucial point here is how all these elements are packaged for the viewer. The visual specs are locked at a cinematic 16:9 aspect ratio, rendered in stunning 4K for a tight 5-minute duration. But the visuals are only half the experience. The audio profile is just as rigid. It specifically requires a professional English male documentary narrator with a calm, deep, cinematic voice. And this voiceover has to be perfectly synchronized with those ultra-realistic visuals. On top of that, the audio mix dictates soft orchestral background music and natural ambient sounds throughout, but strictly no background dialogue. It's essentially a masterclass in controlled, highly immersive digital storytelling.
And really, this whole blueprint brilliantly illustrates the sheer power of modern digital rendering. As we wrap up this explainer, we're kind of forced to ask, with 3D animation rapidly blurring the line of reality, combining physically accurate lighting with hyper-realistic human simulation, how long until we truly can't tell the digital world from the real one? Looking at the specifications in this document, it's pretty clear we're getting closer to that threshold every single day. Thanks for joining me on this explainer. I hope it gave you a cool window into the fascinating, wildly complex world of high-end 3D animation.